Have you ever wondered how automatic streetlights work? Hey guys, in this video, I'll show you how to make a light sensor and a darkness detector. Stay tuned to the second part of this video, where I'll explain how this circuit works. Here are all the components you need to set up this circuit. An LED, any color will do. An LDR or light-dependent resistor. One BC547 NPN transistor. One 1000 ohm resistor. One 470 ohms resistor. 3 jumper wires. A battery holder with 4 AA batteries for the power source. A breadboard to connect everything together. The LDR, or light-dependent resistor, is the key component that detects light. It works by changing its resistance based on the intensity of light falling on it. In bright conditions, its resistance is low, allowing more current to pass through, while in darkness, its resistance increases, restricting current flow. The BC547 transistor acts as an electronic switch. It has 3 terminals: base, collector, and emitter. When a small current flows into the base terminal, it activates the transistor, allowing a larger current to flow between the collector and emitter. Let's set up the circuit step by step. Begin by positioning the BC547 on the breadboard. Insert the left leg of the LDR in the same row as the base of the transistor, and the right leg a few rows below the transistor. Turn the breadboard to the other side. Insert a jumper wire in the same row as the LDR and the positive rail. Insert a jumper wire in the same row as the emitter and the negative rail. Bend the ends of a 1000 ohms resistor. Insert the 1000 ohms resistor in the same row as the base of the transistor and the negative rail. Insert a jumper wire in the same row as the collector of the transistor and a few rows above the transistor. Insert one leg of the LED in the same row as the jumper wire and the other leg a few rows above the jumper wire. The shorter leg is in the same row as the jumper wire. Bend the ends of a 470 ohms resistor. Insert the 470 ohms resistor in the same row as the LED and the positive rail. It's time to connect the power supply. Attach the negative lead from the battery holder to the negative rail. Attach the positive lead from the battery holder to the positive rail. We have successfully completed the circuit. This is a light sensor circuit. When I cover the LDR with my hand, the LED turns off. When I remove my hand and light falls on the LDR, the LED turns on. With some minor changes, I can turn this light sensor circuit into a darkness detector. Start again by inserting a BC547 into the breadboard. Insert the left leg of the LDR into the base of the transistor and the right leg a few rows above the transistor. Turn the breadboard to the other side. Insert a jumper wire in the same row as the emitter and the negative rail. Insert a jumper wire in the same row as the LDR and the negative rail. Bend the ends of a 47,000 ohms resistor. Insert the 47,000 ohms resistor in the same row as the base of the transistor and the positive rail. Insert a jumper wire in the same row as the collector of the transistor, and a few rows above the transistor. Insert the left leg of the LED in the same row as the jumper wire, and the right leg a few rows above the jumper wire. The shorter leg is in the same row as the jumper wire. Bend the ends of a 470 ohms resistor. Insert the 470 ohms resistor in the same row as the LED and the positive rail. Attach the negative lead from the battery holder to the negative rail. Attach the positive lead from the battery holder to the positive rail. This time, when I cover the LDR with my hand, the LED turns on. When I remove my hand, the LED turns off. Let's dive into the circuit and break it down step by step. This is a light-activated circuit, meaning the LED will turn on when light falls on the LDR. The BC547 is an NPN transistor, meaning it conducts current from the collector to the emitter when the base emitter junction is forward biased. That is, when the base voltage is about 0.7 volts higher than the emitter voltage. When bright light hits the LDR, its resistance drops a lot, like to 100 ohms. This makes the voltage near the power supply connected to the transistor's base jump up to around 5.45 volts. That high voltage turns the transistor on, like flipping a switch, because the base is now 0.7 volts higher than the emitter. Current starts flowing through the transistor, and some goes through the 1000 ohms resistor at the emitter, raising its voltage a bit. This lets current flow from the 6 volts battery, through the 470 ohms resistor, through the LED, and through the transistor to ground. The LED lights up, while the 470 ohms resistor keeps it safe from too much current. When it's dark, the LDR's resistance jumps to something like 10,000 ohms, making the voltage at the base of the transistor drop to about 0.55 volts. The LDR and the 1000 ohms resistor split the 6 volts, but the high LDR resistance leaves little for the base. Since the emitter voltage is close to 0 volts, and the base needs at least 0.7 volts more to turn on, the transistor stays off, like an unflipped switch. With the transistor off, no current flows to the LED. That's why the LED doesn't light up in the dark. This darkness detector circuit is the reverse of the light sensor circuit. The LED turns on in the dark and goes off in bright light. The LDR and the 47,000 ohms resistor form a voltage divider or bias network on the transistor's base. In bright light, the LDR's resistance is very low, which typically pulls the transistor's base down or away from the voltage needed to switch it on. The transistor remains off and the LED is off. In the dark, the LDR's resistance becomes very high, and the resistor in the base circuit can now pull the base high enough to switch the transistor on, and the LED turns on. In practice, you can use these circuits to detect whether an area is lit or dark. For instance, if you want a light alarm that turns on an LED in bright light, the light sensor circuit as shown will do exactly that. If you want a night light to turn on automatically in darkness, you would use the darkness detector circuit. I hope this video has shown you how to make a light sensor and a darkness detector with an LDR. If you found this video helpful, give it a thumbs up, consider subscribing for more electronics tips and tutorials, and hit the bell icon to never miss an update. Thanks for watching, and I'll see you in the next video.